International Building Code Section 909.29 mandates that smoke exhaust fans be powered from two power sources. The International Code Council Engineering Code Section 2201 permits specific non-conventional power sources, which includes photovoltaic systems, to serve as alternate power sources. Considering the acceptability of photovoltaic systems as a limited rated surge source, the International Code Council Engineering Code stipulates that a photovoltaic system can function as a limited rated surge source only if it adheres to these requirements. Firstly, the photovoltaic system's dimensions must adequately provide the required surge power for the smoke exhaust fan. Secondly, the photovoltaic system must connect to a battery bank, ensuring sustained power in case of a power disruption. Thirdly, the battery bank's dimensions must provide the required backup time for the smoke exhaust fan. Fourthly, the photovoltaic system and the battery bank must be installed in a readily accessible location. It is vital to ensure that a qualified professional designs and installs the photovoltaic system correctly. Account for potential shading and other elements that could influence a photovoltaic system's reliability. Create a maintenance schedule to guarantee the continuous functionality of the photovoltaic system and battery bank. It's recommended to contact the local building department to get precise requirements for backup power systems for smoke exhaust fans applicable in the specific jurisdiction. Engage an electrical engineer specializing in backup power systems to design and implement a reliable system. Think about employing a photovoltaic system in conjunction with another backup power source, perhaps a generator, to enhance redundancy. Backup power systems are critical for life safety, especially in applications such as smoke exhaust fans. These fans are designed to remove smoke from a building during a fire, providing a clearer evacuation path for occupants and assisting firefighters in their rescue efforts. The International Building Code and related codes, like the International Code Council Engineering Code, establish stringent requirements for these systems to ensure reliability and effectiveness during emergencies. The requirement for two independent power sources is a key aspect of these regulations. This redundancy ensures that the smoke exhaust fan can continue to operate even if one power source fails. This can be achieved through a variety of methods, including a connection to the utility grid and a backup generator or, as this discussion explores, a photovoltaic system with battery storage. When considering a photovoltaic system as a limited rated surge source, several factors must be carefully evaluated. The system's capacity to provide the necessary surge power is paramount. Smoke exhaust fans often require a significant surge of power when they start up, and the photovoltaic system must be capable of delivering this surge without faltering. This involves calculating the fan's startup power requirements and selecting photovoltaic components, such as panels and inverters, that can meet these demands. The integration of a battery bank is crucial for providing continuous power during grid outages. The battery bank acts as a reservoir of energy, storing excess power generated by the photovoltaic panels and releasing it when the grid is down. The size of the battery bank must be sufficient to power the smoke exhaust fan for the required backup time, which is typically specified by local building codes. Factors such as the fan's power consumption and the expected duration of power outages must be considered when determining the appropriate battery capacity. Accessibility is another important consideration. The photovoltaic system and battery bank must be installed in a location that is readily accessible for maintenance and inspection. This ensures that technicians can easily access the equipment to perform necessary repairs and ensure its continued functionality. The location should also be protected from environmental hazards, such as extreme temperatures and moisture, which can degrade the performance and lifespan of the system. The design and installation of a photovoltaic system for a smoke exhaust fan should be entrusted to qualified professionals with experience in both photovoltaic systems and life safety systems. These professionals can ensure that the system is properly designed, installed, and integrated with the building's electrical infrastructure. They can also provide guidance on maintenance and testing procedures to ensure the system's continued reliability. Shading and other environmental factors can significantly impact the performance of a photovoltaic system. Shading from trees, buildings, or other obstructions can reduce the amount of sunlight that reaches the panels, decreasing their power output. Similarly, factors such as temperature and weather conditions can affect the efficiency of the panels. A thorough site assessment should be conducted to identify and mitigate these potential impacts. Regular maintenance is essential for ensuring the continued functionality of a photovoltaic system and battery bank. This includes inspecting the panels for damage or soiling, testing the battery bank's capacity, and verifying the system's overall performance. A well-defined maintenance plan should be developed and implemented to ensure that the system is properly maintained over its lifespan. It is crucial to consult with the local building department to obtain the specific requirements for backup power systems for smoke exhaust fans in the relevant jurisdiction. Building codes and regulations can vary significantly from one location to another, and it is essential to comply with all applicable requirements. The local building department can provide guidance on the specific codes and standards that apply to the project and can review the system design to ensure compliance. In addition to a photovoltaic system, other backup power sources, such as generators, can be used to provide greater redundancy. A generator can provide a reliable source of power during extended grid outages, supplementing the photovoltaic system and battery bank. The combination of a photovoltaic system, battery bank, and generator can provide a highly resilient backup power system that is capable of meeting the demands of a smoke exhaust fan under a variety of conditions. In summary, using a photovoltaic system as a limited rated surge source for a smoke exhaust fan is a viable option, but it requires careful planning, design, and implementation. Adhering to the International Code Council engineering code requirements, engaging qualified professionals, and considering all relevant factors can ensure that the system is reliable, effective, and compliant with local building codes. Smoke exhaust fans are critical components of a building's fire safety system, and their reliable operation is essential for protecting occupants and assisting firefighters during emergencies. Therefore, backup power systems for these fans must be designed and implemented with the utmost care and attention to detail. The electrical design considerations for a smoke exhaust fan backup power system are multifaceted and critical for ensuring the system's reliability and compliance with relevant codes and standards. Firstly, the system must be designed to handle the inrush current of the fan motor. Smoke exhaust fans typically utilize motors that draw a significantly higher current during startup than during normal operation. This inrush current can be several times the motor's rated current and can potentially trip circuit breakers or damage electrical components if not properly accounted for. The electrical system must be sized to accommodate this inrush current and prevent nuisance tripping. Secondly, the system must be designed to provide adequate voltage to the fan motor under all operating conditions. Voltage drop can occur due to the impedance of the wiring and other electrical components in the system. Excessive voltage drop can reduce the motor's performance and potentially damage it. The electrical system must be designed to minimize voltage drop and ensure that the motor receives the required voltage. Thirdly, the system must be designed to protect the fan motor from overcurrent and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, must be installed to protect the motor from damage due to excessive current. These devices must be sized appropriately to protect the motor without nuisance tripping. Fourthly, the system must be designed to provide a reliable ground connection for the fan motor and other electrical components. A proper ground connection is essential for safety and helps to prevent electrical shock hazards. The grounding system must comply with applicable codes and standards. Fifthly, the system must be designed to comply with all relevant codes and standards, including the National Electrical Code and local building codes. These codes and standards specify the requirements for electrical installations and are intended to ensure the safety and reliability of electrical systems. In addition to these basic electrical design considerations, there are several other factors that should be considered when designing a smoke exhaust fan backup power system. Firstly, the system should be designed to be easily maintainable. The electrical component should be readily accessible for inspection and maintenance. The system should also be designed to minimize the risk of damage during maintenance activities. Secondly, the system should be designed to be energy efficient. Energy-efficient components should be used whenever possible to reduce the system's energy consumption. The system should also be designed to minimize standby power consumption. Thirdly, the system should be designed to be compatible with the building's overall electrical system. The backup power system should be integrated seamlessly with the building's electrical system and should not interfere with the operation of other electrical equipment. Fourthly, the system should be designed to be resilient to environmental factors. The electrical components should be protected from moisture, dust, and other environmental contaminants. The system should also be designed to withstand extreme temperatures. Finally, the system should be designed to be cost-effective. The costs of the backup power system should be balanced against its benefits. The system should be designed to provide the required level of reliability and performance at a reasonable cost. The selection of components for a smoke exhaust fan backup power system is critical for ensuring the system's reliability and performance. Firstly, the circuit breakers must be selected to provide adequate overcurrent protection for the fan motor and other electrical components. The circuit breakers should be sized appropriately to protect the motor without nuisance tripping. They should also be selected to withstand the inrush current of the fan motor. Secondly, the wiring must be sized to carry the full load current of the fan motor and other electrical components. The wiring should be sized to minimize voltage drop and ensure that the motor receives the required voltage. The wiring should also be selected to withstand the environmental conditions in which it will be installed. Thirdly, the disconnect switches must be selected to provide a safe and reliable means of disconnecting the power to the fan motor and other electrical components. The disconnect switches should be sized to carry the full load current of the fan motor and other electrical components. They should also be selected to be easily operated and maintained. Fourthly, the grounding conductors must be selected to provide a reliable ground connection for the fan motor and other electrical components. The grounding conductors should be sized in accordance with applicable codes and standards. They should also be selected to withstand the environmental conditions in which they will be installed. Fifthly, the surge protection devices must be selected to protect the electrical components from voltage surges. Voltage surges can damage electrical components and cause them to fail. Surge protection devices should be installed to protect the electrical components from these surges. The surge protection devices should be sized and selected in accordance with applicable codes and standards. In addition to these basic components, there are several other components that may be required for a smoke exhaust fan backup power system. Firstly, the automatic transfer switch. If the system is designed to automatically transfer power to the backup power source in the event of a power outage, an automatic transfer switch will be required. The automatic transfer switch should be selected to be compatible with the backup power source and the building's electrical system. Secondly, the battery charger. If the backup power source is a battery charger will be required to keep the battery charged. The battery charger should be selected to be compatible with the battery and the backup power system. Thirdly, the monitoring system. A monitoring system can be installed to monitor the performance of the backup power system. The monitoring system can provide alerts if there is a problem with the system. The monitoring system can also be used to track the system's energy consumption. The design and selection of components for a smoke exhaust fan backup power system should be entrusted to qualified professionals with experience in both electrical systems and life safety systems. These professionals can ensure that the system is properly designed, installed, and integrated with the building's electrical infrastructure. They can also provide guidance on maintenance and testing procedures to ensure the system's continued reliability. The integration of a photovoltaic system with battery storage as a limited rated surge source for a smoke exhaust fan requires careful consideration of several factors. Firstly, the photovoltaic array must be sized to provide sufficient power to charge the batteries and operate the smoke exhaust fan during normal operation. The size of the array will depend on the power requirements of the fan, the amount of sunlight available at the site, and the efficiency of the photovoltaic panels. Secondly, the battery storage system must be sized to provide sufficient backup power to operate the smoke exhaust fan during a power outage. The size of the battery storage system will depend on the power requirements of the fan, the duration of the expected power outages, and the depth of discharge of the batteries. Thirdly, the inverter must be sized to convert the direct current power from the photovoltaic array and batteries into alternating current power that can be used by the smoke exhaust fan. The size of the inverter will depend on the power requirements of the fan and the voltage of the photovoltaic array and batteries. Fourthly, the charge controller must be sized to regulate the flow of power from the photovoltaic array to the batteries. The charge controller will prevent the batteries from being overcharged or discharged. Fifthly, the system must be designed to protect the photovoltaic array, batteries, and inverter from overcurrent, short circuits, and voltage surges. Overcurrent protection devices, such as circuit breakers and fuses, should be installed to protect the components from damage due to excessive current. Surge protection devices should be installed to protect the components from voltage surges. Sixthly, a system must be designed to comply with all relevant codes and standards, including the National Electrical Code and local building codes. These codes and standards specify the requirements for electrical installations and are intended to ensure the safety and reliability of electrical systems. In addition to these basic considerations, there are several other factors that should be considered when integrating a photovoltaic system with battery storage for a smoke exhaust fan. Firstly, the system should be designed to be easily maintainable. The electrical components should be readily accessible for inspection and maintenance. The system should also be designed to minimize the risk of damage during maintenance activities. Secondly, the system should be designed to be energy efficient. Energy efficient components should be used whenever possible to reduce the system's energy consumption. The system should also be designed to minimize standby power consumption. Thirdly, the system should be designed to be compatible with the building's overall electrical system. The photovoltaic system with battery storage should be integrated seamlessly with the building's electrical system and should not interfere with the operation of other electrical equipment. Fourthly, the system should be designed to be resilient to environmental factors. The electrical components should be protected from moisture, dust, and other environmental contaminants. The system should also be designed to withstand extreme temperatures. Finally, the system should be designed to be cost-effective. The cost of the photovoltaic system with battery storage should be balanced against its benefits. The system should be designed to provide the required level of reliability and performance at a reasonable cost. The installation of a photovoltaic system with battery storage for a smoke exhaust fan must be performed by qualified professionals with experience in both electrical systems and renewable energy systems. The installation should be performed in accordance with all applicable codes and standards. The installation should also be performed in a manner that minimizes the risk of damage to the building or the electrical system. The system should be inspected and tested after installation to ensure that it is functioning properly. The system should also be maintained regularly to ensure that it continues to function properly. The use of a photovoltaic system with battery storage as a limited rated surge source for a smoke exhaust fan can provide a reliable and sustainable source of backup power. However, it is important to carefully consider all of the factors involved in the design, installation, and maintenance of the system. By working with qualified professionals and following all applicable codes and standards, it is possible to create a system that provides reliable backup power for a smoke exhaust fan while also reducing the building's reliance on fossil fuels. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation of electrical systems, including photovoltaic systems. Several articles within the NEC are particularly relevant to the use of a photovoltaic system as a limited rated surge source for a smoke exhaust fan. Firstly, Article 690 covers solar photovoltaic systems. This article provides requirements for the installation of photovoltaic systems, including wiring methods, overcurrent protection, and grounding. It addresses the specific requirements for connecting photovoltaic systems to the electrical grid and for standalone systems that operate independently of the grid. Secondly, Article 700 covers emergency systems. This article provides requirements for the installation of emergency electrical systems, including smoke exhaust fans. It specifies the requirements for the power sources, wiring, and overcurrent protection for emergency systems. Thirdly, Article 701 covers the legally required standby systems. This article provides requirements for the installation of legally required standby systems, which are systems that are required by law to operate in the event of a power outage. Smoke exhaust fans are often considered legally required standby systems. Fourthly, Article 702 covers optional standby systems. This article provides requirements for the installation of optional standby systems, which are systems that are not required by law to operate in the event of a power outage. These systems are often installed to provide additional reliability or to protect valuable equipment. Fifthly, Article 705 covers interconnected electric power production sources. This article provides requirements for the interconnection of electric power production sources, such as photovoltaic systems, with the electrical grid. It specifies the requirements for the interconnection equipment, the protection devices, and the metering. In addition to these specific articles, other articles within the NEC may also be relevant to the installation of a photovoltaic system as a limited rated surge source for a smoke exhaust fan. For example, Article 250 covers grounding and bonding, and Article 300 covers wiring methods. It is important to consult the NEC and all other applicable codes and standards when designing and installing a photovoltaic system for a smoke exhaust fan. The NEC is a complex document, and it is important to have a thorough understanding of its requirements before beginning any electrical work. The National Fire Protection Association, or NFPA, also publishes standards that are relevant to the use of a photovoltaic system as a limited rated surge source for a smoke exhaust fan. Firstly, NFPA 70, which is the National Electrical Code, as previously mentioned, provides comprehensive guidelines for the safe installation of electrical systems. Secondly, NFPA 72, which covers the National Fire Alarm and Signaling Code, provides requirements for the installation, maintenance, and testing of fire alarm systems, including smoke detectors and smoke exhaust fans. Thirdly, NFPA 101, which covers the Life Safety Code, provides requirements for the design and construction of buildings to ensure the safety of occupants in the event of a fire. This code includes requirements for smoke control systems, including smoke exhaust fans. Fourthly, NFPA 13, which covers the installation of sprinkler systems, provides requirements for the installation of sprinkler systems in buildings. Sprinkler systems are often used in conjunction with smoke exhaust fans to control the spread of fire. Fifthly, NFPA 92, which covers smoke control systems, provides requirements for the design, installation, and testing of smoke control systems, including smoke exhaust fans. This standard includes requirements for the performance of smoke exhaust fans and for the integration of smoke exhaust fans with other fire protection systems. In addition to these specific standards, other standards published by the National Fire Protection Association may also be relevant to the use of a photovoltaic system as a limited rated surge source for a smoke exhaust fan. It is important to consult all applicable standards when designing and installing a smoke exhaust fan system. Compliance with these standards is essential for ensuring the safety of occupants in the event of a fire. Proper maintenance and testing of a smoke exhaust fan system are critical for ensuring its continued reliability and effectiveness. Maintenance should be performed on a regular basis in accordance with the manufacturer's recommendations and applicable codes and standards. Testing should be performed periodically to verify that the system is functioning properly. The following are some of the key maintenance and testing tasks that should be performed on a smoke exhaust fan system. Firstly, the fan blades should be inspected for damage or wear. Damaged or worn fan blades can reduce the fan's performance and can potentially cause the fan to fail. Secondly, the motor should be inspected for signs of overheating or other problems. Overheating can damage the motor and can potentially cause the fan to fail. Thirdly, the bearings should be lubricated regularly. Proper lubrication is essential for ensuring the smooth operation of the fan. Fourthly, the electrical connections should be checked for tightness. Loose electrical connections can cause the fan to malfunction. Fifthly, the control system should be tested to verify that it is functioning properly. The control system should be able to automatically start and stop the fan in response to a fire alarm signal. Sixthly, the the airflow should be measured to verify that the fan is providing the required airflow. The airflow should be measured using a calibrated airflow meter. Seventhly, the system should be visually inspected to ensure that there are no obstructions to airflow. Obstructions to airflow can reduce the fan's performance. Eighthly, the backup power system should be tested to verify that it is functioning properly. The backup power system should be able to automatically provide power to the fan in the event of a power outage. The results of all maintenance and testing should be documented. This documentation should be kept on file and should be available for review by building officials and fire inspectors. Regular maintenance and testing can help to ensure that a smoke exhaust fan system is ready to operate when it is needed most. This can help to protect the lives of building occupants in the event of a fire. The use of a photovoltaic system with battery storage as a limited rated surge source for a smoke exhaust fan can be a cost-effective and environmentally friendly solution. However, it is important to consider the life cycle cost of the system when evaluating its overall cost-effectiveness. The life cycle cost includes the initial cost of the system, the cost of maintenance and testing, and the cost of energy consumption. The initial cost of a photovoltaic system with battery storage can be significant. However, the cost of the system can be offset by the savings in energy costs over the life of the system. The cost of maintenance and testing should also be considered. Regular maintenance and testing are essential for ensuring the continued reliability and effectiveness of the system. The cost of energy consumption should be considered as well. A photovoltaic system with battery storage can reduce the building's reliance on fossil fuels, which can result in significant savings in energy costs. In addition to these direct costs, there are also several indirect costs that should be considered. These costs include the cost of permitting, the cost of engineering design, and the cost of installation. The permitting process can be complex and time-consuming. The cost of engineering design can vary depending on the complexity of the system. The cost of installation can vary depending on the size and complexity of the system. When evaluating the cost-effectiveness of a photovoltaic system with battery storage, it is important to consider all of the direct and indirect costs. It is also important to consider the benefits of the system, such as the reduction in energy costs and the improved reliability of the smoke exhaust fan. By carefully considering all of the costs and benefits, it is possible to determine whether a photovoltaic system with battery storage is a cost-effective solution for a particular application. In some cases, a photovoltaic system with battery storage may not be the most cost-effective solution. In these cases, other backup power systems, such as generators, may be a better option. The best option will depend on the specific requirements of the application.